Okay guys, today we are going to read an article called Chilling Out, Warming Up, How Animals Survive Temperature Extremes. So I'm going to read the article to you and then I will upload this to Edpuzzle so that you guys can add or answer some questions along the way as well to make sure we're understanding about different animal adaptations and how they use these adaptations to survive temperature extremes. So here we go. Animals have some amazing adaptations that help them live in even the most hostile environments. Consider camels, for instance. They can thrive in some of the hottest and driest places on Earth. Their legs don't get burned when they kneel on hot sand due to thick, leathery patches on their knees. They can survive for an entire week without water, but at the same time, they can drink 32 gallons of water at once. Their body temperature ranges from 93 degrees Fahrenheit to 107 degrees Fahrenheit, so they don't need to sweat very often and can conserve water this way. The spongy bones in their noses absorb any excess moisture to keep every drop of water in, so the air they breathe out is dry air. In addition to camels, other animals' adaptations are equally remarkable. How do they do it? Chemistry helps. Warm-blooded or cold-blooded. The most important adaptation is how animals regulate their body temperature. Animals can either be warm-blooded or cold-blooded. Warm-blooded animals, which are mostly birds and mammals, need to maintain a relatively constant body temperature. The body temperature of most mammals ranges from 97 degrees Fahrenheit to 103 degrees Fahrenheit, while birds have an average body temperature of 105 degrees Fahrenheit. For humans, the commonly accepted average body temperature is 98.6 degrees Fahrenheit, even though it may vary according or among individuals. Cold-blooded animals do not maintain a constant body temperature. They get their heat from the outside environment, so their body temperature fluctuates. Based on external temperatures, if it is 50 degrees outside, their body temperature will eventually drop to 50 degrees as well. If it rises to 100 degrees Fahrenheit, their body temperature will reach 100 degrees Fahrenheit. In most instances, the size and shape of an organism dictate whether it will be warm-blooded or cold-blooded. Think about some large animals, elephants, whales, and walruses. Their volume is so large that relying on the outside environment to heat them up would be inefficient and would slow their response times, putting their survival at risk. For that reason, nearly all large animals are warm-blooded. What about all the birds and mammals that are not large, such as mice and sparrows? The other factor, body shape, comes into play here. Small, warm-blooded animals tend to have a rounded shape, which ensures that the interior of an organism stays warm the longest time possible. Most cold-blooded organisms have either an elongated or a flat shape. If you look at a typical fish, their bodies tend to be flat when viewed head-on from the front. Snakes, lizards, and worms tend to be long and slender. These shapes ensure that they can heat up and cool down rapidly. Page 2. Within a given species, animals tend to be larger in colder climates and smaller in warmer climates, an observation known as Bergmann's rule. For example, white-tailed deer in the southern part of the United States tend to have a smaller body size and less overall mass than white-tailed deer in the far northern states. There are exceptions, but overall this rule holds true for the following reason. As the volume of an object decreases, the ratio of its surface area to its volume increases. In other words, the smaller an animal is, the higher the surface area to volume ratio. These animals lose heat relatively quickly and cool down faster, so they're more likely to be found in warmer climates. Larger animals, on the other hand, have lower surface area to volume ratios and lose heat more slowly, so they are more likely to be found in colder climates. That's the end of this video for today. You will have some questions to answer along the way. Make sure you've answered every single question because it's going to help you do well on your test. And then we will read the next section, Generating Energy, tomorrow.